The Western Carpathians are an arc-shaped mountain range, the northern branch of the Alpine-Himalayan fold-and-thrust system called the Alpide belt, which evolved during the Alpine orogeny. In particular, the pre-Cenozoic evolution is very similar to that of the Eastern Alps, and they constitute a transition between the Eastern Alps and the Eastern Carpathians. The geological evolution of individual parts of the chain is complex, a result of tectonic processes like folding, thrusting and the formation of sedimentary basins of various types during the Mesozoic and Cenozoic. These processes sometimes affected not only the sedimentary fill of the basins but also, in some cases, the former basement. Many aspects of the geological structure of the Western Carpathians have not been completely studied and are subject to ongoing research and debate. The appropriate classification of a number of specific tectonic units is still not clear. Geological definition. The Western Carpathians are separated from the Alps by the valley of the river Danube and the rubber line. To the east, the boundary with the Eastern Carpathians is placed formally in the valley of the river Uzh, but many tectonic divisions consider the Hornad fault system on the line Koshitsa-Presov the real geological boundary. The northern boundary is the thrust front that separates the nappes from the Carpathian foredeep. In Bohemia, the line Znojmo-Prerov-Karvina approximately forms the western boundary of the Western Carpathians. The southern boundary is not distinct. According to some views, it is south of the Basin Mountains in Hungary. Geological structure. There are several interpretations of the tectonic structure of the Western Carpathians. For quite a long time, the triple division has been used, while some geologists prefer the classical double division. Other ideas of division may differ, such as morphotectonic or regional geology. Tectonic division applied in this article is based on the division of Plazienka and others in 1997. Later modified in 1999 and in 2002 together with Kovac, although it cannot be considered definitive. The three main areas of the inner, central, and outer Western Carpathians are divided by two sutures. The Mellie suture is an area of closure of the Triassic-Jurassic Mellie Ocean during the Cimmerian phase. It constitutes the boundary between the central and inner Western Carpathians. The position of the boundary is disputable. Different authors place the Mellie suture in different areas. It is identified with the Rosnava line, Lubanic-Margikani line, or possibly placed even more to the south. The second important suture is called the Peri Pian lineament, roughly copying the structure of Pianini Klippan belt. This important dislocation divides the central and outer Western Carpathians. Deeper under the sediments, it constitutes the boundary between the Central Carpathian basement rocks and the foreland, the Bohemian Massif and East European Cratan. Since the 1980s, the dividing line has been considered the suture of the Varic Ocean, the eastern continuation of the Piedmont-Liguria Ocean. The foreland of the Western Carpathians in the west and north is composed of the Bohemian Massif and Krakow Plateau. In the northeast, it is formed by the rock of the East European Cratan. These areas were consolidated earlier than the Carpathians. The Bohemian Massif, which is the youngest part of the foreland, evolved during the Hercynian orogeny about 200 million years before the orogeny in the Carpathians. Outer Western Carpathians. The Outer Western Carpathians were formed during orogeny that took place since the Upper Cretaceous and Miocene periods, which is later than the Central Western Carpathians. Pianini Klippan belt was affected by thrusting together with the Central Carpathians and later folded and thrusted again together with the Fleisch belt. Foredeep thrust of the Carpathians on the foreland caused a flexure of the lower lower continental plate under the frontal part of the nappes. This flexured area, called the Carpathian foredeep, was filled by thick formations of molasse, prevailingly marls, sandstones and conglomerates that were formed in the Oligocene to Miocene periods by erosion of the growing Carpathians. Nevertheless, the foredeep is not generally folded. Flysch nappes thrusted from the south partially folded the rock underneath. The whole zone of the foredeep is developed in the foreland of the Alps, and runs through the Moravia to the Ostrava Basin and further east to Poland, Ukraine, and Romania. Flysch belt. The Flysch belt was named after a characteristic alteration of sandstone and claystone, so-called flysch, occurring in the Cretaceous to Paleogene age in the area. The belt is the accretionary wedge of the Carpathians. The Flysch belt also contains a small volume of Cenozoic volcanic rocks. The zone originally consisted of a set of more sedimentary basins that were in constant tectonic transformation. Raised parts of the basins formed elevations, which were eroded and supplied deeper parts of the basin with clastic sediments that were brought by turbidity currents. Orogeny affected the area at the end of the Paleogene and in the beginning of the Neogene in the so-called Savian phase. Other portions were also affected by the Starian phase, which caused partial thrusting over the foredeep. Nappes were formed by gradual compression of the sedimentary basins that caused their inversion and separation of sedimentary successions from their basement and the movement for distance of 20 to 30 kilometers, and possibly more. Nappes were formed in two phases: the outer or lower group of nappes called the Silesia-Krosno belt, and the overriding internal Magura belt. Nappes are thrust over the foreland in the form of tectonic slices. At least part of the Flysch belt was an eastern continuation of the Alpine-Penninic zone, probably the valley branch. A direct continuation of the Alpine Rhine-Danube Flysch can be seen. The Flysch belt continues through Bohemia, Slovakia, and Poland, and joins the Moldavian Flysch in the Ukraine and Romania. Central Western Carpathians. The Central Western Carpathians, sometimes referred as the Slovako-Carpathian system, are a zone bounded by the Pieniny-Klippen belt from the north and the Meliata belt from the south. The Pieniny-Klippen belt is a relatively thin but important dividing line separating the outer Western Carpathians from the internal zones of orogeny. Together with the similar units of the Peri-Klippen zone, it constitutes the Povesi-Pieniny belt. The largest portion of the Western Carpathians consists of the zone built of granitic and metamorphic rock and sedimentary cover overridden by thrust nappes of Mesozoic carbonate rocks. The zone consists of the Tatra-Fatra belt of core mountains, the Vepa belt, and the Gemma belt. In the predominantly crystalline basement zones called the Tatric, Vephoric, and Gemmeric, thrusting is also present but not as apparent. Geophysical investigation confirmed that the Gemmeric is thrusted over the Vephoric, and the Vephoric over the Tatric. The Central Western Carpathians formerly constituted a portion of the East European Cratan continental shelf, and were situated more to the west, in the area of the present Switzerland, laterally joining the Outer Carpathians. During the release of tension within the Alpine collision tectonic events, the stress was released to the flanks of the thrust belt, which caused the tectonic escape of the material. Central Western Carpathians were consequently pushed in the northeast direction from the Alpine to Carpathian domain. Povesi-Pieniny belt. The Povesi-Pieniny belt has a complicated imbricated structure, represented especially by the Pieniny-Klippen belt. It consists of Orovage-Gossau groups and Magura units, as well as Slovako-Carpathian units. Placement of the Pieniny-Klippen belt into the Central Western Carpathians is ambiguous, because most authors consider Pieniny-Klippen belt as part of the Outer Carpathians. The Povesi-Pianoni belt is divided into three zones: the Brezova, Peri Pian, and Klippen zones. Relatively thin and complicated, the Pianoni-Klippen belt creates a boundary, a tectonic suture, between the outer and central Western Carpathians. Only rock younger than the Triassic is known in this zone. Exclusively non-metamorphic sedimentary successions are composed especially of limestones and marls. In the Jurassic period, the ocean that opened in the area of the Pianoni-Klippen belt is called the Varich Ocean. Its preserved sedimentary successions are in the present erosion cut known only from the Varich unit. The Varich domain was bounded from the north by the slopes of the Orovich, and from the south by the Tatric unit. The subsiding part of the Orovich unit formed the Kaisuka Basin. The most shallow part of the Orovich unit was characterized by a deposition of shallow water limestones of Zorsten unit. To the south, closer to the deep water Kaisuka Basin, other transitional units were deposited. In the deepest part of the Kaisuka Basin, sediments of Kaisuka Pianoni unit were deposited. The Varich domain had extended and deepened during its history. In the Upper Cretaceous to Paleocene, the thrusting of the southern units of Tatric caused inversion, a subduction of the Varich Ocean that was followed by collision of the Orovich and Tatric units. As a result of these processes, deformation and north-vergent thrusting of the Orovich units in the form of nappes occurred. After the end of compression, marly and flysch-like sedimentation continued on the top of the nappe stack. Later in the Paleogene, another phase of orogeny affected the Pianoni-Klippen belt. It squeezed the former nappe stack, and the rocks of different rheology were deformed in different ways, which caused the rupture of more dense rock and ductile deformation of the less dense rock. Complicated arrangement of particular tectonic units was later affected by strike-slip motion in the area of the Peri Pianoni lineament in the Miocene. Consequent erosion dissected the rigid limestone tectonic lenses to the shape of protruding clips. The zone of clips stretches almost uninterrupted from the Podbranch in western Slovakia to the Poiana Botize in northeastern Romanian Tatrafatra belt of core mountains south of the Pianoni-Klippen belt. The zone of core mountains is present. The core is formed by the Tatric unit, composed predominantly by Paleozoic metamorphic rock, younger plutonic rock, and Carboniferous to Mesozoic sedimentary cover. Basement rock was formed during the Hercynian orogeny when a strong regional metamorphism affected the area. Paranises and amphibolites are most abundant, but low-grade metamorphic rock is also present. Later, at the end of Hercynian orogeny in the Carboniferous and Permian, the area was intruded by granitic rock and strongly affected by erosion, which affected even the deeply situated granites. The autochthonous Carboniferous, Permian and most commonly Mesozoic sediments are onlapping the crystalline basement. They are represented by greywacke, quartz sandstones, shales, limestones, and marls. Sedimentary cover of the Tatric unit is overridden by Mesozoic nappes. Nappes are large slabs of the Mesozoic carbonate rock with similar sedimentary sequences present in the Tatric cover. There are two so-called subtatric nappes, the lower called the Kisner nappe and the upper called Chok nappe. The Fatric is characterized by the occurrence of thicker formations of the Carpathian coipa. The Rhonic is typical, with the occurrence of Permian andesitic basalts and a larger thickness of variable Triassic carbonate rock. Thrusting of the nappes took place in the Upper Cretaceous, probably during the Turonian. The whole area was not so rangy as it is today. Uplift of the mountains took place at the end of the Oligocene and in the Miocene. It caused the uplift of the horsts, usually asymmetric, on the south flank, steeply bounded by normal faults and slightly declining to the north flank. The crystalline basement is usually uncovered on the south flank of the horsts. The horsts form two rows of mountains. The northern row consists of the Mellie Carpathi MTS, Hovascianovec MTS, Strazovsky Vrchy MTS, Malafatra MTS, and Tatra MTS. The southern row of core mountains includes the Tribec MTS, ZR MTS, Velka Fatra MTS, Choksky Vrchy MTS, the eastern part of Niski Tatry MTS, and Branisko MTS. Vepa Belt. The Vepa Belt is zone south of the belt of core mountains. The dividing line is called the Satavika line. A characteristic feature of the Vepa Belt is medium alpine regional metamorphism. The largest area of this zone is formed by the Vephoric unit. Crystalline basement rock is most abundant in this area, and the largest granitic pluton in the Western Carpathians is present here. It was formed during the Hercynian orogeny. Mesozoic sedimentary cover is preserved only locally. The Vephoric unit was the root area of the Krishna Napi that was formerly situated in the inverted Salayachov basin on the northern rim of the Vephoric, close to the Tatric. Inversion of the basin took place in the Upper Cretaceous and was accompanied by intrusion of a small body of granite. In addition to Napi outliers of the Chok Napi and part of the Krishna Napi, there is also a large body of Miran Napi. The Vephoric is partially thrusted over the Tatric and lies under the Gemeric unit. The Napi stack of the Vephoric and Gemeric later collapsed and evolved in the Vephoric metamorphic core complex. The Vepa Belt forms the eastern part of the Niski Tatry MTS, Vepa MTS, Kozy Chrbty MTS, southern portion of the Branisko MTS, and Sierra Hora MTS. On the south it is divided from the Slovak Ore Mountains by the Lubenik-Margikani line that is a gently dipping thrust fault. Gemma Belt. The Gemma Belt is a zone of predominantly crystalline rock partially thrusted over the Vephoric. The most important portion of the zone is the Gemeric unit. Unlike the other Carpathian units with signs of low-grade Hercynian metamorphic overprint, the Gemeric is the uppermost basement-involved unit of the central Western Carpathians. It is made by phyllites, quartzites, porphyries and limestones commonly metamorphosed to siderite and magnesite. Granites are less abundant. Permian volcanic activity formed the uraninite mineralization. Later, during the Mesozoic, limestones and dollostones were deposited. In the Upper Jurassic, after the closure of the Meliata Ocean, naps of the Meliatic and Tornaic were thrust from the south. In the Upper Cretaceous, Silicic Napi was thrust over the previous. At the end of Paleogene, the Gemeric belt was deformed and uplifted. This zone forms the Slovak Ore Mountains, Galmus, and Slovak Karst. Internal Western Carpathians. The internal Western Carpathians are divided from the central Western Carpathians by the Rosnava line, which is partly covered by the Decollement naps. The Rosnava line is largely a conceptual one and is perceived differently by different authors. According to assumptions, the fault joins the Rabuhobanovo line on the west. The problem of exact definition of boundary between the internal and central Western Carpathians are views of the structure of the Meliatic unit. The internal Western Carpathians are composed generally of the tectonic units originating from the area of the former Meliata-Hallstatt ocean ore. South of it, this zone is built of the Meliata, Buck Transdanubian, and Zemplin belt. There are large naps of Mesozoic carbonates, which are not affected by metamorphism and are characteristic with typical affinity to the South Alps dinorite facies. Melliata Belt. The Melliata Belt is a remnant of the Triassic-Jurassic Melliata Ocean. The principal structural unit of the belt is meliatic, composed of rocks of the subduction melange, deep-water shales, radiolarites, basalts of oceanic type and marbles. The unit of the uncertain arrangement, which is according to some authors part of the meliatic, is the Borca-Napi, composed of the obducted blue schists. The silicic and tornaic unit probably originate from the southern continental shelf of the Melliata Ocean. The silicic is the nappy characteristic with larger thickness of shallow water limestones of wetistine facies. The tornaic nappy was probably a transitional area between the silicic and meliatic. Naps in the Melliata belt were thrust to the north and now consist mostly of outliers lying on the Gemeric and Vephoric units, constituting the Slovak karst and Agtlale karst on the Slovak-Hungarian border. Buck Belt. To the south of the previous area there is the Bukic unit, which bears the signs of the transitional zone between the Western Carpathians and the Dinarides. Rock of the Bukic occurs in the North Hungarian mountain buck. It consists generally of the Paleozoic shales, carbonates, and sandstones, but also overlying younger Mesozoic carbonates and volcanic rocks. Sedimentation continued to the Jurassic when the nabs of unclear vergence were thrust. The zone was later in the Cretaceous affected by low-grade metamorphism. During the subduction of the Melliata-Hallstatt Ocean in the Upper Jurassic, the Bacarc Basin evolved. This basin was later inverted and it was probably the root zone of the Monosbel Zarvasco Napi. Transdanubian Belt. The Transdanubian of the Bacani Belt principal tectonic unit called the Transdanubicum occurs in the Transdanubian Mountains. It consists of the low-grade metamorphic Paleozoic and Mesozoic rock and Cenozoic sedimentary cover. Zemplin Belt. A tectonic unit of uncertain position is the Zemplinic in the Horst of the Zemplin MTS, emerging from the Cenozoic sedimentary fill of the Eastern Slovakia Basin. The Zemplinic is according to some authors either assigned to the separate belts or considered as a part of the separate terrain Dacia. Some geologists assign it to the southern Vephoric, the Gemeric unit, or even to the Eastern Carpathians. The Zemplinic is the only place of occurrence of the Precambrian rock in the Western Carpathians. They are composed of the Paranaises, amphibolites, and migmatites, together with post-Hercynian Carboniferous and Permian conglomerates and thin beds of black coal. Post-Napi units. The Jurassic-Cretaceous tectonic structure was later changed by various types of the overstep complexes. The Central Carpathian Paleogene Basin, Buda Paleogene Basin, Vienna Basin, Pannonian Basin, and the volcanic complexes. Neogene volcanics of Carpathians. Volcanism. Paleozoic and Mesozoic volcanism. The oldest forms of volcanism, which affected the area of the Western Carpathians, are hardly recognized because of later tectonic processes and destruction by erosion. Significant volcanic activity took place in the lower Paleozoic in the Mallee Carpathy MTS, where the relics are seen in the rock of the Pernek group with typical basic volcanism. Large volumes of volcanic rock, considered a product of stratovolcanoes, significantly changed by metamorphism, are present in the Gemeric. Basic volcanism is recognized in the Carboniferous and Permian rock. Among the Permian rock, the Ipoltico group of the Ronic Napi is best known. The lower part of the group is called the Maluzino Formation. It is characteristic of sedimentary dacity to andesite volcanism in the lower part and andesitic basalts close to the thalitic type in the upper part. Nodules of hydrothermal agate are common in the cavities of these rocks, widely known as the melophyres. According to some authors, Permian volcanism in Ronick has polyphase linear character. Mesozoic volcanic processes are more distinct and known from all zones of the Western Carpathians. There are Triassic effusives in the rock of Fatric and Ronick of the Malafatra MTS, and Niski Tatri MTS. Picrites are known around Banska Bystranka. Cretaceous tessonites were found in the Silesian zone of the Fleisch belt. Remnants of destructed ophylites with NMORB basalts in the upper part are present in the rock of the Meliatic. Cenozoic volcanism. Post-Napi volcanic activity in the Carpathians is simply called neovolcanism. It took place from the Neogene to the Quaternary, mostly in the internal portion of the Carpathian arc. Three main phases of the volcanic activity are distinguished. Acid volcanism began in the Lower Miocene in northern Hungary and later extended into the territory of present Slovakia. It is represented by rhyodacite rhyolitic rock. This type of volcanism is called the aerial type because of its large aerial extent. In central Slovakia, volcanic rock formed the Polana, Kremnica, and Vidicnik MTS. Rhyodacite tuffs in sediments of Lower Bodinian are known in the Zemplin region of eastern Slovakia. Intermediate volcanism started in the Lower Bodinian, and from a petrological point of view it represents calcaline andesites to dacites, related to subduction of the ocean floor in the Fleisch belt and related formation of the volcanic arc. Volcanism started in a subaquatic environment near the Sahi-Lisek zone of the Krupina plain. Later a massive stratovolcano of the Polana, Javri, Lisek, Silovska, and particularly the Stiavnica stratovolcano and volcano in the Kremnica mountains. After a period of strong erosion, the volcanic activity restored in Upper Bodinian. Restored volcanism was more explosive. In the Slovak Or Mountains, significantly eroded remnants of former stratovolcanoes comparable to the central Slovakia ones were found. In the Lower Sarmatian, a subduction process in the present eastern Slovakia resulted in the formation of a line of geomorphologically simple stratovolcanoes of the Slanske VRCHYMTS. Volcanoes of this phase are found also in Romania. The younger phase of volcanism is known in the area of Vihorlar MTS. Basic volcanism, represented by alkaline rock, is found in central and southern Slovakia and Hungary. The prevailing rock type is basalt with phenocrysts of olivine and nepheline. There were lava flows in the vicinity of the Ostraluka near Zavolen and Device near Krupina, lava flows and Mars in the vicinity of Pinchina, Jelsovek, lava flows, next dikes, and Mars in Sarova Urchovina, and the youngest cinder cone, the Putikov VRSOK, near the Nova Bana. Metamorphism. The occurrence of metamorphosed crystalline rock in the Western Carpathians is known from the Tatric, Vephoric, Gemeric, and Zemplinic zones. Existing research has clearly demonstrated traces of the Hercynian and Alpine orogeny, although some authors suggest the possible presence of the older Cadomian and Caledonian metamorphic cycles. Existence of the Precambrian metamorphic cycles was not confirmed because of the later metamorphic overprint. Caledonian metamorphism has not been clearly proved, but some signs are present in amphibolites of the Mallee-Carpathy MTS, or the granite of Silla type in the Vephoric. More common is the Hercynian metamorphism, which is associated with regional and periplutonic metamorphism caused by intrusions of granitic rock, diaphoresis and low-grade metamorphism of volcanoes, sedimentary formations of several tectonic
tectonic units to the greenschist facies, signs of the Alpine metamorphism, which took place 75–107 million years ago, are well preserved in the Mesozoic formations of the Tatric, Gemeric, and especially Vephoric. Special subduction-related metamorphism to blueschist facies is known from the Volcanic